I'm Anil Kumar, and in this series, we are practicing how to factor quadratic functions. Now, here we have taken a few examples where the leading coefficient is 1. So, we are factoring trinomials where a equals to 1. And remember, always it is important to note that factor if possible. There could be few trinomials which cannot be factored. Since when we are factoring, we are looking for integers, right, which could be one of the factors. So sometimes we could have rational numbers or real numbers. So we are not including those into this factoring exercise. So keep that in mind. Okay. So we'll factor trinomials where a is equals to 1. The method being applied is product and sum. Okay. So the method is product and sum. What does that mean? It really means that the constant here should be product and the term, which is coefficient of x, should be sum of two numbers. So in every case, we'll look for two numbers and we'll say p and q are our numbers whose product is the constant term, which is 4 in this case, and whose sum is b, which is 5. Is it okay? That is what it is. As you can see, 4 times 1, when you multiply, gets 4, and when you add, you get 5. So that becomes the solution. So we could factor this and write this as x plus 4 times x plus 1, correct? So it's factors. So one step, provided you get this combination. If you don't get this combination, then you cannot factor. That's why we have if possible. Is it okay? So we'll continue with this technique and quickly go through the list. So we are looking for two numbers. So we'll say product is 24, correct? And the sum is minus 9. When the sum is minus 9, the bigger number, here the sum is product is positive, so both are same sign. Is it okay? Both same sign. So 24 is, how do you get 24? You could get 24 by 24 and 1, right? Both have to be negative since this is negative. That doesn't work as sum. You could have 2 times 12, that doesn't work. 3 times 8, that doesn't work. 6 times 4, that doesn't work, right? So it does not work. So it is not possible. So we tried all, but we could not get this combination, so it is not possible. Perfect. So that is what I'm trying to say, if possible. Now, I would like you to pause the video, copy these questions, solve them on your own. Be clear that some of them cannot be factored. Is that okay? Now let's go ahead. The next question here is kind of tricky. We have switched, right? So let me rewrite this question. X square first. So always write in proper order. X square minus 10x plus 16. That is the proper order, right? Highest degree first and then decreasing. Product, we are looking for 16. And sum, we are looking for minus 10. Correct? 8 times 2. Both negative. So we could write this as 8 minus 8 and minus 2. Perfect. That works. Next one, we're looking for a product of minus 20 and sum of minus 8. So minus 8 is the sum. So two numbers with different signs, correct? So 10 and 2 can work. Bigger one should be negative. So it's minus 10 and plus 2. So we could write this as x minus 10 times x plus 2, right? So that is how it should be done. Now here we have x squared, 12xy, 35y squared. So we're looking for a product of what? 35y squared, right? So the product should be 35y squared and the sum should be 12y, correct? 7 times 5 works for you. So we'll write x plus 7y, right? And x plus 5y. Perfect. Now we have to look for product of minus 32. And sum of plus 14, right? So 14, and we are looking for 32. 32 you can get as 16 times 2, right? 16 times 2. Since we need positive, we'll have 16 times minus 2. So we get x plus 16 times x minus 2 as our solution. Is it okay? Here we have x squared plus 7x minus 6. So we're looking for product of minus 6. So two numbers with opposite sign and the sum of plus 7. So plus 7 you can only get if I do 6 times 1, both positive, which is not possible. So that is not possible, right? And the last one here is, let's look for that. P and Q, we want minus 24, and sum, which limited P plus Q, is minus 11. So 8 times 3 could work, okay. However, to get negative, one of them should be negative, the other positive. So that doesn't work, right? Because this is negative 2. So this is also not possible. Is that okay? So this is also not possible. It could have been possible if this sign was positive. Do you see that? But not in this situation. Correct? Same here. If this would have been positive 6, we could do it 6 times 1. So that is how actually you can apply product and sum method to factor trinomials where a is equal to 1. So in the next video, we'll see if a is not 1, then how to do it, right? The method of product and sum will be applied, but we will add one more step here to do it. I'm Anil Kumar, and I hope that helps. Thank you for watching, and all the best.